Okay, Mr. Antonucci here, and we're in part three. Check the conditions for a test about the distribution of a categorical variable. So as with other significance tests that we've looked at, the three conditions still apply when we perform a test about the distribution of a categorical variable. The random condition, the data have to come from a random sample of the population of interest. The 10% condition, if you're sampling without replacement, is that your sample size has to be less than 10% of the population which you're sampling from. And the large counts condition is a little bit different here. All expected counts have to be at least 5. Okay? We talked about how to calculate expected counts in the previous video. So make sure you were looking at the expected counts, not the observed counts. And that's our AP tip. When you check the large count condition, make sure you address the expected counts, not the observed counts. Make sure to write the expected counts on your paper and label them as expected counts, or you won't receive credit. And never round them to the nearest integer because they're what you would expect in the long run, so you can think of them as long run averages. So even though you might be talking about a discrete data like the number of people or the number of um, bananas or something like that, the expected counts can be decimal values. So let's take a peek at an example. So here is the table of observed and expected counts for a test of the null hypothesis and population of the population proportions of NHL players born each quarter. Okay, so we want to check whether the conditions are met for performing a test about the distribution of a categorical variable. So first thing we're going to do, make sure the values of that you're using the values of the expected counts when checking the large count condition. Okay, so first one is random. The setup to the problem said it was a random sample of 80 NHL players. So make sure you write that out as a sentence. Don't just write the word random and put a check mark next to it. Okay, the 10% condition. Um, it, we must assume that 80 is less than 10% of all NHL players. It's reasonable to assume that, even though it's not specifically stated that there's more than like 800 players. Oftentimes, when you're doing this, you may not know the population size, but common sense and just some simple reasoning you can assume that the 10% condition is satisfied. Now, if you have the specific population and it's not satisfied, then it's not satisfied. And then here's what we're talking about with the expected counts. All the expected counts are at least 5. Remember, we calculated them before, and they're each 20. So we have all the conditions satisfied for a chi-square test for goodness of fit. And that's it for this one. Again, hope that was helpful. Reach out if you have any questions.